This is Shiksha Vinay, and I am going to teach you kinematics for study 9. The topic of today is projectile motion. So, what is projectile motion? I have given you some figures that a ball is in motion in different situations. For example, a ball is thrown horizontally towards east. In this case, the ball going down vertically towards the ground, or in this case, ball is going upward vertically. But in this case and in this case, it's covered a curved line path like this, or also you can say there's a parabolic path. When you throw a ball obliquely, then it traces the path which is called parabola. Parabola actually means, bola means ball, para means path. A ball covers the path which is known as parabola. Have you got my point? So what is projectile motion? First of all, I have to know what is projectile, or what is projection. So here, to throw something is known as projection. So here I throw a ball in the sky. That means the ball undergoes projectile motion. No matter how you throw the ball, in which direction you throw the ball, along which line you throw the ball, no matter. But if you throw the ball in the sky, from above or from bottom, from ground or from your roof, no matter, these kind of motion are called projectile motion. This can be 1D or this can be 2D. As if ball moves along the same line, then this motion is called 1D motion, 1D projectile motion. When body moves along two lines, or you can say curved line, as you see in the situation here, 4th and 5th, when the ball moves obliquely or in a curved path or in a parabola path, then we say that it covers 2D, means its measurement towards along this line and along this also, because it moves up also, it moves towards east also. So there are two measurement or direction involved in this motion. That's why it is called 2D motion. It is called 2D motion. But these three motions are 1D motion because it involves only one direction or along one line. Have you got my point? So 1D motion has 1, 2, 3 situation. I have already told you. Situation 1, 2, 3 are 1D motion, 1D projectile motion, and 4 and 5 are 2D projectile motion. Have you got my point? Now I have to deal with 1D projectile motion. So what we will study in this lecture for projectile motion, we discuss simple cases of projectile motion first, then we deal about lift problems, and another is weightlessness, and then relative motion or thief police cases or car racing cases or overtaking cases. So now I am giving you simple cases. Suppose a ball is dropped from some height. Let's say it is from point A. Sorry. A ball in your hand and you throw the ball vertically above in the sky. What happens in this case? Surely ball decreases its speed and at a point it becomes 0. So it covers the maximum height and the speed becomes 0. I represent this point as A here. Now ball again move towards your hand, because there is acceleration always acting on the ball at every instant of time. This is acceleration due to gravity. It never ceases. Velocity maybe ceases because when ball go up, acceleration is in the direction towards the earth, so speed decreases. So at a point its speed becomes 0. And then body moves towards your hand with the increasing speed, because here acceleration is in the same direction as the direction of motion. So speed increases and again reach at your hand. This is the situation I have given you. So in this case, in this motion, what do you think about it? From B to A means from your hand to the topmost point. What information you can get? Take at velocity u, you have thrown the ball above. So this velocity is initial velocity, and I have written u as ub because here point name is B, so I am taking ub as u. Initial velocity is u, by which you throw the ball in the sky. And at the top, the velocity or speed becomes 0 because acceleration is towards the earth but motion is towards the sky. That's why speed decreases, and at a point speed ceases completely at all. And in this motion we can say this is deceleration because the speed decreases, because the direction of acceleration is not in the direction of motion. That's why we can say A is equal to minus G. Have you got my point? So can you find in this situation from B to A what is the S and what is the time taken to reach at the topmost point? It is so simple. You have known already the equation of motion. You can apply it and you can find the result. So I have done in front of you that B square must be equal to U square plus 2S, and here B is 0 and U is UB and S is unknown. I have to find out. Let S is H, means height. So it becomes U square by 2G, UB U square by 2G, or you say UB square by 2G. And in the similar way you can find out time with the help of equation of motion. Can you find T is equal to U by Z, or you can say UB by Z? Can you find it? Now in the next case, when ball moves from top to bottom, top to your hand, what information you can get from this kind of situation? Surely initial velocity during this motion from top to bottom is 0, because in the previous case B to A, the velocity at A is 0. Now in this case A to B, the initial point is A and final point is B, so initial velocity is here 0. Have you got my point? So initial velocity is 0. And what is the acceleration? I have already told you the acceleration is always same at every point of instant, because it depends on the earth gravitational field. So it is z at every point of time, and the direction is fixed toward the center of the earth. But ball, when ball go up, it becomes retardation, it decreases the speed. But when ball goes down, then its speed increases because it gives acceleration, positive value of acceleration. That means A is equal to plus Z. So you can find S and T by using equation of motion. That becomes UB squared by 2Z. Can you find it? And you can find also time. Oh no, I'm going wrong. This height never change, because from top to in your hand and hand to the top, the displacement is same, height is same. So you can mention it here. That height is already known to you. You have calculated it in the previous case. Yes or not? So here three things are given. Height is given, acceleration and initial velocity. You can calculate the final velocity as well as time. So how can you calculate? Here Vb is equal to u and time t is same as u by g. You have to solve it. You can solve it. It is very easy, applying equation of motions. So what conclusion you get from this observation? I have concluded that time taken from ascending the ball and time taken from descending the ball is same. And from going up the ball at a particular point, ball have same speed. When I throw, the speed of ball is ub, and when I take again the ball, the speed is same ub. Have you got my point? From this situation, I have concluded this kind of information. Now I give you more discussion about what conclusion I have got, and it is very necessary to understand that the speed at my hand when ball go up or when go again come to my hand is same u, and the speed at point A is 0, 0, going up, going down. Have you got my point? So it is ascending, ascent, it is descent. Time of ascent is same as time of descent, and the speed is also same at a particular point. Now if I say the speed, what is the speed or magnitude of a speed at point C here? This C is when ball is moving up. This same C is when ball is going down. Are these velocity are same or different? You can calculate it, and as your surprise, you will find that the speed is same at every point of instant, whether going or down or going up. And the time between 2 points, here I am taking from hand to C, from C to hand, time taken is also same. So time of ascent is equal to time of descent for a particular level or particular point during the motion. Have you got my point? Now, in another case, if I take time between these two intervals, not from my hand, but between two instant, let's say E and D, and then also the time of ascent is equal to time of descent in every cases, and the speed is same when going up, going down, V2, and the speed is same here also, E going down, going up, U2. So what we have learned in this situation, that time of ascent equal to time of descent for between any two particular instant, or at any instant for going down or up, speed is same. In the projectile motion for 1D case. So I have written about it at the same level or instant, velocity same but direction opposite, because you have seen that in one case ball is going up and in another ball is going down. So direction is, or time taken is same as ascending in as well as descending. I am giving you some try at home problem. You have to solve it because it is easier for you. You have to apply the the equation of motion, and also the conclusion you have already studied in this lecture. So here is the problem. You can write it and try it at your home. And another question I give you. I hope you have written and you have to solve it at your home, because it is necessary for a skilling in physics. Now, in this lecture, I am giving you another lesson about effective acceleration. What do you mean by effective acceleration? When two acceleration comes at the same time, then the net effect of acceleration is known as effective acceleration. I give you some cases. It is also called lift problem. So if a ball falls in a lift and lift is going down with acceleration A, what happens if I see from outside or from the ground? I am not in the lift, but ball is in the lift, and from the window I am seeing the ball. Will the ball move with same acceleration, same speed, or it may appear differently for me? And what happened to those who are in the lift? My dear learner, I am saying you that for both the observers, the motion of ball become different. They appear different because the reference frame for me is ground, but the reference frame for the observer which are in the lift is lift itself. That's why due to change in reference frame, the motion appear differently. So if a man is in the lift, then ball will fall with the same acceleration as acceleration due to gravity. But if I am here on the ground and watching the motion of the ball through the window of lift, then I will perceive different motion than the man who perceive from the lift. Have you got my point? So in this case, I will perceive the acceleration of ball decreases, means it becomes slower for me, but for the man in the lift, it is as usual. The velocity changes as per the rate of acceleration due to gravity. But if I perceive from the ground, then the acceleration or speed changes slowly as compared to the man which sit in the lift. Have you got my point? I'm not going to discuss why it happens, because it may be it may take another term which is called pseudo force, which we'll deal about in the force chapter. I'm not going to discuss here. But you have to think about why it happens without taking scientific terms. You can think by your own self or by your own term. But why it happens? Why acceleration decreases? So here I am writing wrongly, and that gives here g minus a, because the acceleration of ball is g here and a, so it becomes g minus a. I've got my point. Now it becomes g plus a because the acceleration of the ball going up is g and the acceleration of lift is a. It means its speed decreases or increases or changes very fastly. Have you got my point? Means ball will strike this top point in very lesser time. Have you got my point? But here ball will hit this bottom in very is taking much time to strike bottom of the lift. You can think it is not so hard. So I am giving you some situation that you have to say about it. What is the effective acceleration in this case? If the acceleration is up and ball is going down. If ball is going up, acceleration is also up, and the acceleration is g. The acceleration of ball is also g, and acceleration of lift is also g, going up. What is the effective acceleration in this case? You have to work it out. Thinking is essential part of any kind of learning, and physics demands thinking more. Now I'm giving you some try at home problem. Suppose you are at here in the lift and you throw a ball vertically at 2 meters per second, and the lift and the size of lift from bottom to top is 10 meters, and the lift is going down by 5 meters per second square as acceleration as rate. So my question is how long it will take to reach the floor of the lift, and how much distance is covered during the whole journey. And another problem, you can create more problems by yourself, giving different situation in the lift. Like lift moves up, lift moves down with constant speed. Sometimes it may have constant speed. Sometimes it may have constant acceleration. Sometimes it may go up, it may go down. Sometimes ball go up and go, sometimes ball go down. So you have to create situation and take some data for it, value for it, and then solve it out by yourself. If you face difficulty, please contact Shiksha Vinaya or mail me. I will help you every time. Now the next topic for this lecture is weightlessness. What do you mean by weightlessness? Means the feeling that I have no weight. This is called weightlessness. Or the feeling that my weight is reduced. This kind of thing is called weightlessness. So here I give you situation for your understanding that I have a weighing machine. This is a weighing machine, and I have a let's say cabbage. I keep it here on the weighing machine, and it weighs 5 kg. But actually it weighs 50 Newton. But you are familiar with only kg. So it may read here in kg, but actually it reads 50 Newton. Have you got my point? So now the weight of this cabbage is here 50 Newton. Suppose table is slipped by my kick on which the weighing machine is kept, and the weighing machine began to fall on the ground. Now I see the reading of weighing machine during the fall. What happens? Does weight remain constant, that is 50 Newton? Does it less than 50 Newton or greater than 50 Newton, or it weighs no weight at all? What is your answer? Can you think? Can you observe? If you can think, you can understand on which thing weight depends, on which factor weight depends. Surely weight reduces. And in this case, weight becomes 0, and the cabbage have no weight at all. You don't have to pay money. So you have to go to shopkeeper and tell to the shopkeeper that you have to weigh the cabbage when during the fall, and then I pay you some money. And in this way your pocket money will not be reduced by reducing its weight. Okay, now if you have think or observe that to have weight, what are the factors? First of all, it must feel gravitational pull of any planet or any star or anything which is near to it, and some surface. Without surface, no force at all. For example, in a space there is no surface, so you feel, or astronaut feel, weightlessness. Surface is necessary. Now if you are on the surface and there is no pressing as in the space, if there is a weighing machine at the bottom of your foot, how much weight it reads in the machine? Obviously it reads null or empty or no reading at all. Why? Because even if you have surface to press, you cannot press it in space. Just think about it. It is so strange thing. I have a surface, but I cannot press it. So surface is necessary, but it is not the essential thing. You have to press it. Now if I press something, then I have weight. You will study it in the chapter 4, that it is called normal reaction given by pressing due to third law of motion. So normal reaction is necessary to have weight. So this is the thing that I have given you in this lecture. So enjoy the motion by thinking, by solving more and more problems. If you face difficulty, please contact Shiksha Vinaya or mail me anytime. Thank you watching this lecture.